All right. Hello and welcome to the CySA Plus study session for December 14th, 2022. I'm Arami and I'll be hosting the session. You can join us on Discord or on Twitch at these addresses. Question number 1. During our development of a new program, it is important that we revisit each step to ensure nothing is missed. It is imperative that the program work without flaws as will be used in a medical facility. What SDLC framework best suits our needs? Is this waterfall, rad, spiral, or agile? So, during our development of a new program, it is important that we revisit each step to ensure nothing is missed. It is imperative that the program work without flaws as it will be used in a medical facility. Which SDLC framework or model best suits our needs? Is that waterfall, rad, spiral, or agile? All right. So let's see what the let's let's see what the answer is here. If you had said spiral, you would be right. So spiral revisits each and every stage multiple times, right? So we start off with planning and development. We come out and we go around and do our development, whatever, and then we go back to planning and development again. Like if we started here, when we circle around, when we get to here, we're back to planning and development. We keep spiraling out like that, and we keep doing that until the program's done. Agile is going to use something called sprints, where you're making something, like planning, basic stuff, and then it says, okay, I'm going to make the login interface, and then they go through the whole little, like a small um, development phase where they work solely on the login thing, right? And then they they do some planning, and then they work on the interface, and then that's another sprint, which is another little circle. So it's like a straight line, straight path, has a circle, kind of like a roller coaster, and then it has another circle, and each of these circles is called a sprint. So if we're talking about sprints, we're talking about agile, but in this case, we want to revisit each step, so that's definitely going to be spiral because we'll even revisit the development steps. Waterfall can make it back to the development steps, but waterfall can only ever change one step in either direction, right? So to make it all the way back to planning and things of that nature, we have to go back through all the other steps and go, okay, well, this thing didn't work. Go back to the previous step. Ah, it's still not working. Go back to the previous step. And then you also have RAD, which is for rapid deployments, where you make the thing and then you revise the thing and revise the thing and revise the thing. It's very little planning, and it's just kind of like get it done, get it out there. But Spiral is the only option here that guarantees that we will revisit each step and be able to re-examine individual portions of it. Question 2. It's going to be a SDLC heavy session today. What is being done in the implementation phase of SDLC? Is the application being installed on testing systems? Is the application being installed on production systems? Is the software being worked on in the dev slash staging environment? Is the software's basic function Are the software's basic functions being planned out? Or is the software being designed and prototyped? What do you think's happening in the implementation phase? Do we know all of our phases and how many we have? So what's being done in the implementation phase? Could that be we're installing this on testing systems? We're installing the application on the production systems. Is the software being worked on in the dev/staging environment? Are the software's basic functions being planned out? Or is the software being designed and prototyped? Not all of it. Not all of it's SDLC. It's just very SDLC heavy. I think I got 5 questions here that I wrote for SDLC. So yes, they're all these are all my questions. Yeah. Uh, I for the recorded sessions I have to write my own questions so I don't go over any copyright infringement from someone else. So yeah. Okay. So let's see what the answer is. What is being done in the implementation phase of SDLC? Let's actually go over all the phases of SDLC. And I've kind of sorted them here. I've left 2 phases out, so I've added them in. But the first stage is planning, where we're looking at the viability and if we're reinventing the wheel. Can I just go buy some off-the-shelf software and use it? And I don't even have to write my own software. That means I don't have to maintain it. I mean, someone else gets to do all that fun stuff, right? The second stage is requirement analysis. That's when we're figuring out what the software's basic functions and requirements are. Um, we're figuring out what needs to be accomplished by our software. What task is it performing? What hole is it filling? The third part is design. This is where we are going to write the pseudocode and the logic flowcharts. Like, if user fails to validate, disconnect user, right? It's not that simple when we're coding, but we can get the general flow chart of the logic down instead of saying, if user fails to authenticate, tell them if the username or the password is wrong. That would be a bad thing, right? We would be leaking important information about the data that was entered. In this case, implementation is the fourth stage. This is where the software is going to be worked on. This is where the actual coding is happening. Um, Implementation always makes you think about, oh, it's being installed. We're implementing the technology. We're using the technology. No, this is the way of calling development and coding. Implementation, development, coding. The fifth stage is testing and integration, right? This could be user acceptance testing. Um, this could be stress testing. Any of those tests where we're making sure that, hey, this software is not going to screw up, right? This is where we would do our fuzz testing. All that good stuff. Our next stage is deployment, or as I like to call it, trial by fire. You put it out there and you hope that you caught all your bugs and have fixed everything at this point. It's probably unlikely that you've caught every bug, but most of them should be out of the system and you should be able to keep running. And that goes into our seventh stage, which is operation and maintenance. That's where we're going to monitor the application. We're going to patch it. We're going to continue updating it for all those bugs that we're finding after we've released it in the sixth stage. Uh, I think SDLC is becoming part of Security Plus now, right? The new Security Plus is covering SDLC, and it looks like the new CySA is not covering it. Um, oh yeah, and I've also added questions from some of the new CySA topics in this one as well. All right, question 3. When we are in the fifth stage of SDLC, which is testing and integration, what technique might we use to test handling of inputs? Would that be input validation, fuzzing, static analysis, or Fagan testing? So in the fifth stage of SDLC testing and integration, what technique might we use to test handling of inputs? Would that be our input validation, our fuzzing, static analysis, or Fagan testing? If you said fuzzing, you'd be correct. Input validation is not a testing method for input, but it is something we should do and preferably do server side to prevent cross-site scripting and SQL injection and other attacks. If done on the client side only, an attacker could use a proxy and evade our protection. Fuzzing is when we manually or automatically input strange, unexpected data and try to cause programs to crash, give up credentials, or perform unexpected actions. Static analysis is when we look at the code of a program to determine its functionality and danger level, right? We don't actually run it here, we're just decompiling it. We're looking for signatures or functions that are clearly malicious. Uh, we have plenty of programs that can do that for us. I think Immunity Debugger is a pretty good one. I think VirusTotal does static analysis and dynamic analysis. You can also hash the program, submit that to the VirusTotal, which is super useful because we can change the name of a program, right? Just because it's called svchost.exe does not mean it's svchost.exe. We also have Fagan testing. Fagan testing is formal code review. It's usually internal to the company, developing the code. It could be outsourced, but it's definitely like other programmers looking at your code to make sure, hey, there's nothing weird going on here. This isn't best practices, things of that nature. Question 4. A company wants to be able to test parts of a new program as they become available. What would be the best SDLC framework to use to allow this testing? Would this be waterfall, rad, spiral, or agile? We want to be able to test parts of a new program as they become available. What would be the best SDLC framework to use to allow for this testing? Waterfall, rad, spiral, or agile? If you said agile, you'd be correct. So waterfall would not be useful in this situation since we need parts of the program to test while we continue to develop other parts of the program, and waterfall does not focus on separate parts of a program. Waterfall's focusing on the entirety of a program, right? RAD is also focusing on the entirety of the program. RAD stands for Rapid Application Development. We would not be getting just parts of the program like the login part and then the interface part to play with and then the bulk of the program or whatever. It involves minimal planning and iterative development, i.e. a lot of versions very quickly. Spiral, again, does not give us portions of the program while the team works on other parts. The development in the Spiral SDLC is fast, but both requirements are not met. Agile develops in sprints, giving us portions of the program to test, while other parts are still under work in development. One of the top 5 benefits of Agile is the development speed. So Agile is not only very fast, but it allows you to test portions of the program without the entire program being finished first. Which of the following types of data is closely related to PCI DSS? Is that SQL, DLP, TLS, SSL, or CHD? This comes from the CS 0003 objectives. Which of the following data types or types of data is closely related to PCI DSS? SQL, DLP, TLS, SSL, or CHD? If you said E, CHD, which is cardholder data, you would be correct. Cardholder data includes the PAN, which is the permanent account number, which is the 16-digit number there on the front of your card, the cardholder name, expiration date, and CVV. So SSL is outdated. It was replaced by TLS. People still say SSL like it's a thing. Like, oh, it uses SSL. No, it uses TLS. A lot of people think they're ubiquitous, but SSL is the older technology here. TLS, we should probably be using TLS 1.3, but it isn't what we're looking for in this case, right? So we should probably use TLS if we're doing like online banking or online ordering of packages or something of that nature. You know, gifts for Christmas, which is coming up. But that's not what we're talking about. We're talking about a type of data that is most closely related to PCI DSS. DLP, again, something we should probably be using, right? We don't want Vic sending out everyone's credit card data to hackers for a quick buck, you know, from the HR office. We just don't want that to happen. Yep, I will use your names. You kind of submit to that when you join the channel. SQL, great for databases, and we might use a database in our payment processing, but it's not closely related to PCI DSS in this case. Okay, identify the main parts of a SOAP message. Select all that apply. This is definitely a CS002 question. What are the parts of a SOAP message? Is that the message, the body, the encoding type, the header, the fault, the stamp, the envelope, or the environment? All right. So we want to identify the main parts of a SOAP message. Message, body, encoding type, header, fault, stamp, envelope, or environment. So the best way to look at this is if we look at an actual SOAP message. Well, the outline of one at least, right? SOAP message could be really, really long. So let's look at one. So the answer here is body, header, fault, and envelope. We start off noting that SOAP is XML, right? We're using XML version 1.0. The SOAP environment, but that's not really, it's just kind of describing the SOAP packet. Here we have the envelope, and we say, or that could, yeah, basically be, here you go. Here's all the information. This is where we're going to lay out the pattern that you're going to be looking at and the encoding style. It's a style, not, and it's just pointing off to it. So if even encoding type, I guess I could have given that to you. But we have the header, right? From who to who, all the good stuff. The body and the fault. And then we close the fault, close the body, close the envelope. But the four main parts are body, header, fault, and envelope. If I'm using John the Ripper to crack a Windows password file, what file or files do I need from the target to perform the attack? Is that the SAM file, the ntpasshash file, shadow file, password file, or passwd file? If I'm using John the Ripper to crack a Windows password file, what files do I need? Okay. What files do I need from the target to perform the attack? SAM file, ntpasshash file, shadow file, password file, or passwd file? If you said the SAM file, you'd be right. You don't technically need the NTLM. You don't have the NTLM as a selection here, right? I said NTPass because I had to change it. I wanted to make it seem like, you know, maybe there's more than one thing. But the SAM file and NTLM hash files are for Windows-based systems and would be valid targets for John if we were attacking a Microsoft Windows-based OS. The most common place to find these files are in the, I just did / because I can't tell you what letter drive yours is going to be on, but your Windows directory, system32 /SAM directory. Linux uses two files, the etc shadow and etc passwd files, but these do not exist on Windows, so we couldn't use those to crack a Windows password. We would also need to run unshadow against these files before we began cracking the passwords, or our attempts will fail. On Windows, we don't have that prerequisite to have to unshadow. Password and ntpass aren't real file names by default on a system. Doesn't mean we couldn't create them. Oh, come on. What tools could I use to get around client-side input validation? Would that be Nmap, Burp Suite, Nessus, OpenVAS, or Zap? Okay, what tools could I use to get around client-side input validation? Could be more than one, right? So we have Nmap, Burp Suite, Nessus, OpenVAS, or Zap. All right, so question 8. If you said Burp Suite and Zap, you would be correct, right? So Burp Suite definitely has a proxy built in. It can do all kinds of stuff. It does more than just proxy. It has replay. It has attacks. It has password cracking. I mean, it's a great tool. Zap is made by OWASP, right? It's also called the Z-Attack proxy. So proxy's even in the name, and you can easily get around client-side input validation with either of these tools. I guess an honorable mention for me should go out to developer tools. If you hit F12 on your browser and you pull up developer tools and you're willing to go through all the pain of reading all that stuff, it'll work. But to me, it's very tedious and painful to do it that way. I like the Burp Suite or Zap interface. Nmap is a multi-purpose tool mainly used for scanning ports and helping identify services and operating systems. It can also tell us some vulnerability scanning if we use SC um, to do like the common script runs against certain services. It can tell us what version, whether it's vulnerable to something. It could even enumerate some stuff for us, right? I think there's a SMB enumeration script for it even. Nessus is a web-based vulnerability scanner. It doesn't have the ability to proxy a connection or change messages going between you and a server, but it's really nice to be able to see your vulnerabilities and go look at the CVEs and see what you have to do to patch things, right? OpenVAS is also a vulnerability scanner. There's no proxy here. It does along the same lines of what Nessus does. Question 9. Where would each of the following most likely be located? Is this an internal network, external network, or isolated network? So for A, B, C, D here, we're going to say it's either going to be the internal network, external network, or isolated. So for A, an air-gapped database that stores keys and certificates. Why is it certifications? B, a user workstation at the office. C, our server that is located in the DMZ that runs our website in the data center. D, our API that queries the inventory server to check availability of stock. Where would these servers be? Where would these servers? Where would these servers be located in our network? We have the options of internal network, external network, or on an isolated network. Our four situations are: we have an air-gapped database that stores keys and certs. We have a user workstation at the office. We have our server that is located in the DMZ that runs our website in the data center. And we have our API that queries inventory servers to check availability of stock. All right. An air-gapped database that stores keys and certificates would be isolated, right? So air-gapped means that we have no network connection, thus we are isolated from the network. A user workstation is going to be on the intranet of our company. That would be on the internal network. He's definitely behind the firewall. The firewall is pretty much where we're going to, or I should say our external firewall, right? Our very first firewall furthest out towards the internet. That's going to be like the demarcation point for whether we're external or internal. The guest network could also be considered external. I should have put that on there too. So if you had a guest network, guest wireless network or something, yeah, that could be external. You probably don't want them having access to all your internal resources. Our server that is located in the DMZ that runs our website in the data center. The DMZ is external, right? So this server probably has multiple interfaces on it. Um, this is kind of a trick question because really it fits two different things, right? So the web page interface would be in the DMZ, so people could access our web page and perform queries and see what we sell and maybe buy something, hopefully, right? But we'd also probably have an internal connection on another interface that would interface with things like the CRM server or our stock and management servers and things of that nature, we might actually have to have some connection on either side. So really it could be external and internal in this case. But because it's in the DMZ, I was really going for external on this one. Our API that queries the inventory server to check availability of stock. APIs like this are external facing. Um, Not all APIs are web services, right? All web services are APIs though. So when we're talking about an API on the internet, you can think of it as a web service. It might be api.tryhackme.com, but that API, that's really a web service. It's just a subset. And some APIs are free. Some may charge you. Um, Typical uses of APIs could be like Google Translate is an API. It'll go to a web page and automatically translate from whatever language to your language. It makes it way easier on you, and it's a great API, right? Um, I did a little bit of research to make sure I had enough information about this. There's a Chuck Norris API that randomly chooses Chuck Norris facts. So, I mean, I'd have to go look at it. I didn't look at it, but I thought that was kind of funny. It was in like the top 22. So, Chuck Norris still very relevant in the world today, apparently. But an API would be external facing, right? Because you may need another website to query whether or not you have this in stock. Maybe um, one of your other websites or is selling stock as well, and you're checking to make sure you have black T-shirts in stock so you can print the other logo on it. Okay, question 10. We're going to go through an Nmap question, and it's pretty. You pretty much have to know what the switches are in Nmap to get this one, I think. But if I want to scan the 192.168.1.1/24 network as quickly as possible and only want to look for DNS, NetBIOS, session, HTTP, HTTPS, and SMB, what command would best suit my needs? Which one of these would I use here? We want to look at the 192.168.1.1/24 network. We want to do it as quickly as possible, and we only want to look for DNS, NetBIOS session, HTTP, HTTPS, and SMB ports. What command would best suit my needs? Okay, so this one is pretty difficult. So let's do a little bit of a breakdown on what these things are. All the ports are correct, right? I haven't changed the ports between them. I've changed a little bit of like flagging between each. SV is the service version detection. It can take a while sometimes. I mean, if you want a really, really strong scan, you do like a SV with SC. You get all kinds of data, but it takes forever. So both of those take a long time. SC is running against common scripts. Um, Great for trying to find vulnerabilities, but that's not what we're doing here. We just want to see if these ports are open. SU is for scanning UDP ports. DNS is running on UDP, but the rest of these are TCP ports. So if we did SU, we could see if DNS is open, but the rest of the ports would be like, no. It would probably show filtered or other issues. If we did ST, we're only doing a TCP scan, so that wouldn't work for UDP, which would be our DNS. ST, it will do the full three-way handshake, right? Which makes it pretty slow. If we do STU, it tells us that we're both looking for UDP and TCP ports. When we specify ports with U colon or T colon, we can specify if that port is UDP or TCP. So this would probably be our best choice, looking directly for knowing DNS is 100% UDP on port 53, right? We would do UDP 53. Um, we have NetBIOS for 139 TCP, HTTP, TCP port 80, HTTPS, TCP 443, and SMB, TCP 445. So this is one of those commands where it's actually really useful to know ST and SU, and this is how you would combine them. So those are our 10 questions for this week. I'm going to stop the recording at this point.